Hi and welcome to this amazing section that we are going to learn about handling activity lifecycle and configuration changes. Activity lifecycle is one of the core and at the same time important aspects of an Android app to understand and also handle, especially if you would be willing to add fragments to your activity. And about configuration changes. Things might not always work as you expect them to. Just a rotate or a touch on back button can change the game and make your application crash or lose data track. This section is all you need to know to handle activity lifecycle and handle configuration changes. By the end of this video, you are going to explore activity lifecycle. The more you understand an activity lifecycle, the better you'd be able to use each event. Every activity have their own life cycle. As the user interacts with them, they start, they get created, get paused, stopped, and so on. These are the main events that happen to an activity, and with the help of these functions, the activity lets the system know that it's in a new state. The life cycle events are predefined in the Android system itself. You just need to override them in your activity class in order to access them. For further customization, when you want to react to these events, for example, think of this easy scenario that you might want to save the user information. If by any chance the user navigates to another app without clicking on the Submit button. In this slide, you can see a simplified illustration of activities lifecycle and the callback events that help activity to transit between stages. You probably don't need to implement all the lifecycle methods, but it depends on your application and how complexible it is. However, it's important that you understand each one and implement those that ensure your app behaves the way user expects it to. So for now, let's move on and learn about them in detail. The onCreate. This callback must be implemented. The system fires the onCreate and creates the activity, and so it enters the created state. In the onCreate method, you perform basic application startup logic that should happen only once for the entire life of the activity. The onStart. Your activity does not reside in the created state. After the onCreate method finishes execution, the activity enters the started state, and the system calls the onStart and onResume method in quick succession. When the activity enters the started state, the system invokes this callback. The onStart call makes the activity visible to the user, as the app prepares for the activity to enter the foreground and become interactive. For example, this method is where the app initializes the code that maintains the UI. The resumed. Once the resumed callback finishes, the activity enters the resumed state, and the system invokes the onResume method. When the activity enters the resumed state, it comes to the foreground and then the system invokes the onResume callback. This is the state in which the app interacts with the user. The app stays in this state until something happens to take focus away from the app. And so, what happens next? An event like receiving a phone call, the user's navigation to another activity, or the device screen's turning off might happen. When this kind of interruption occurs, the activity enters the paused state and the system invokes the onPause callback. The onPause. The user is leaving your activity and the activity won't be on the foreground, but it might be still visible only in multi-window apps or when the activity has no focus, like when a dialog opens. Alright, now after the onPause method is completed, the activity stays in the paused state until the activity resumes or becomes invisible. In the case of being resumed, it goes back to the onResume event, but in case of going invisible, it goes to the stopped state and calls the onStop event. Remember that you don't need to reinitialize your components that you created before when you go from paused to resumed. The unstop. When the activity is in the stopped state, it is no longer visible to the user. This callback is fundamental when you want to shut down the CPU-intensive operations. And here is the proper place for the relevant codes. For example, data you need to save. When your activity is in the stopped state, the activity object is still kept in the memory. It maintains all states of infos, but it's not attached to the window manager. And when the activity resumes, the activity recalls this information. And so what happens after this? The activity either comes back to interact with the user, or the activity is finished running and goes away. If the activity comes back, the system invokes onStart. If the activity is finished running, the system calls onDestroy. And onDestroyed, it is called right before the activity is being destroyed. And when is it invoked? When the activity is finishing, due to the user completely dismissing the activity, or due to finish method being called on the activity, or the system is temporarily destroying the activity due to a configuration change, such as device rotation. We will talk about the configuration changes soon. And furthermore, you need to know that the onDestroy callback should release all resources that have not yet been released. Perfect!